Instead, it is propelled into space, where it is trapped by the gravity of the Earth, still only 86,000 miles away. Some of these rocks hurtle toward our planet.
You actually would have seen a huge plume of debris rise up off the lunar surface. This cloud, in fact, would have enveloped the entire lunar surface, and out of that cloud there would have been fragments of rock that pelted the Earth. They would have streamed through the atmosphere as intense fireballs to land rocky components on the Earth's surface.
These lunar meteorites are incredibly rare. This is part of one of only 30 lunar meteorites ever found.
So this is a sample that fell in Africa. Analyses of samples like this tell us that there was a cataclysmic spike in the number of impact events that affected the moon 3.9 to 4 billion years ago.
Lunar meteorites contain a record of the geological history of the inner solar system as it was around 4 billion years ago. These rocks are older than the oldest rocks on Earth. The existence of lunar meteorites on Earth started scientists wondering if rocks can be catapulted from the moon to Earth. Could rocks from the Earth also reach the moon? And if such Earth meteorites could be found, might they hold fascinating clues to what was happening on Earth billions of years ago? To blast anything free from Earth's strong gravity requires immense force. Far more power than it takes to launch a lunar meteorite off the surface of the moon. For example, the Space Shuttle uses 15 million horsepower to escape from Earth's gravity. The lunar module needed just 6,300 horsepower to lift off from the moon. But just how big an impact would it take to blast debris off of the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has figured out the answer to that question.
The crater in northern Arizona, Meteor Crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the moon.
Impacts on Earth during the lunar cataclysm are far bigger than the dinosaur extinction event. They impact with such power that they punch holes in the Earth's atmosphere. Rocks and debris thrown skywards escape through these holes. Once in space, some of the debris is vacuumed up by the moon, orbiting just 86,000 miles away.
And it eventually makes its way to the moon, where it lands. And then when it lands on the moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Landing on the lunar surface, they remain perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that more than 1,000 pounds of Earth rock could be spread over every square mile of the moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the moon, they're preserved there in a pristine form. There's no water cycle on the moon, there's no more active geology, and they get buried relatively quickly from the material from other impacts on the moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the moon. Gonzalez will have to wait until the next moon mission, in the hope that these priceless rocks may then be discovered. The first half-billion years of the Moon's journey from Earth has been a violent one. Over the next billion years, the Moon continues its escape from Earth and out into space. Its passage changes the face of our planet beyond all recognition. The power of its gravity creates tides thousands of feet high, stirring up the oceans of the Earth. This creates the conditions for complex chemical compounds to form. The Moon is aiding the creation of life on Earth. 3 billion years ago, the Moon is still escaping from the Earth, and it now orbits almost 200,000 miles away. The effect of its gravity is weaker, but it still has the power to radically change our planet. For now, the Earth has water and oceans, and the Moon is stirring things up. It's too far away to have a dramatic effect on the rocks of the Earth, but the Moon is affecting the oceans. As the Moon passes overhead, its gravity creates tides in the water. But these are not like the tides of today. These are thousands of feet high. Astronomer Neil Cummins studies how the early Moon affected the tides.
When the Moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contains minerals and nutrients. The tides created by the Moon churn these into the most crucial cocktail in the history of Earth, the primordial soup. Different combinations of minerals are bound together and torn apart. It's in this violent melting pot that the right combination of minerals is forged into life. Cummins believes that the spark of life might never have occurred without the Moon's power to churn up the primordial soup.
The Moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may have even helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides go in and out cause the DNA to split and replicate. The enormous Moon-induced tides have a further vital role to play in the history of the Earth. They help the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life can evolve. In our look back to 3 billion years ago, the Earth is a very different place. The impact that creates the Moon sets the Earth spinning faster. It spins so much faster than it does now that a day lasts just 6 hours. This high-speed spin has devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere. The faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whips over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.